Afternoon, Tony Peters again with another update. It's the same day. This is just part 2. So a couple different things I'm working on. We talked about the artificial sun module subsystem, basically what's going on the end of the beta angle position and control subsystem. So what are you actually trying to maneuver around? Well, there's a couple different things. This is the ASMS is broken up into 2 layers, I guess you could say. The solar test array layer 1 and solar test array layer 2. Test array layer 1 is this right here, so it looks a little bit different than what I had before. So I've got I sent out a picture with the specific description. So I got a 5 milliwatt laser here at 625 nanometers used for calibration and testing, so you can kind of see exactly, point it at something and get an idea of what exactly your array is pointing at and at what angle. And then this also going to come into play later on when we talk about reflections, so you can kind of gauge what angle you're going to be at in order to pick up any kind of optical losses on the second layer, which I'll talk about here in a second. So anyway, I've got my red, green, blue, white LED sequence in different configurations as you go around. I demonstrate some of the solar test array code in that regard. Here I've got the UV and IR LEDs. The UV is at 365 nanometers, so you can see it and it gives off a kind of a violet hue, and the infrared at, well, obviously outside the human visibility spectrum, but you can use a digital video camera to actually pick them up on like older cameras and stuff to make sure that they're actually blinking and coming on. So I've tested this, I've done my continuity checks and made sure that everything works well. So I'll just kind of demonstrate just some basic things here. So this is what the UV LEDs kind of look like. So I'm not pointing them directly right at the camera. So everything's kind of offset in these little configurations here. So let me unplug this. And we'll talk about the second layer of the solar test array. And essentially what it's going to look like is you put this straight through it, and then you orient this off to the side. Boom. I'll take some more pictures so you can get an up-close view of exactly what everything is doing. But again, this requires, I have a completely separate microcontroller controlling everything with their own pull-up resistors, etc. I'm trying to work on some things over here to work that, and then I'm consolidating all of that into this PCB. I'm still wiring it up, so you basically just drop in your controller, plug everything in on the end of your first layer of the array, and then you integrate that into your second layer, which is all this right here. And again, I'll give a demonstration of what exactly everything looks like right now. I haven't finalized how I want to display the information specifically, but I'm starting to remove more and more pieces and trying to consolidate and get these 2 individual layers ready to be put into one module. So let me just plug this in, and you can get a clear idea what's going on. It might be a little difficult to see. Let me turn this light off actually so you can potentially get a better idea, because on mine it's not very easy to see. Well, from where my camera is anyway. So essentially I have a couple different things here that's going to give me pertinent information. So this entire array obviously is mounted behind the first one, and if I bring my hand closer or farther away, it's going to give me the range. It's going to give me the temperature of my hand, in this case the photovoltaic that I want to look at, and it's also going to give me the temperature of the source. It has an internal temperature sensor, which is really nice. The other things that it's going to be giving me is we'll to be looking at reflections. I sent out that point paper on luminosity. So these sensors over on this side, this wing, I guess you could say I put on here, has 2 different sensors, and it's giving me an error because of the distance sensor. So it's actually going to give me 2 different types of indications. One is my UV intensity in milliwatts per centimeter squared, as well as my visibility in terms of lux, or my visible spectrum intensity in terms of lux. Again, I covered a lot of that in the point paper. This is exactly what I'm trying to do in application of it. So I can explain a little bit more in detail at one point, but like I said, this was just supposed to be a demonstration for showing you exactly what's going on, what I've built up, how I'm planning on putting this together. So long story short, I'm going to take this second layer, connect it with the first layer, finish up my driver board for it. So I hit a button, it tells me exactly what light is on. I'll know what wavelength that corresponds to. I might as well just do this for a second because it's just going to keep giving me errors. And I'm going to mount that to the top of the beta angle position control subsystem arm. And then I'm going to start getting some calculations and start seeing how everything works and integrates. Now that I've got a working model for my BAPSIS, my ASMS I'm going to finish putting together, and then I got to put this thing in a box to environmentally control and regulate everything. So that'll be in there. And I've completed the ECMS a little while ago. And then the last part of this is getting a baseline. So how am I going to get a baseline? Right now this is just very rough, but I've got a couple different sensors here on something that I'm going to mount and cut out and do all this stuff with. Obviously, because I'm not ordering PCBs online that are pre-printed based off my own specs, because a lot of it's kind of on the fly because my requirements keep changing and I want to keep adding things. But essentially what I'm going to do is all my sensors are pretty much located right around here. And this is going to go straight on top of my BAPSIS overlay here, or my thermal base plate. And what's going to happen is each one of these sensors is going to give me something unique to read. One of them is going to give me my IR intensity in terms of lux. The other one's going to give me my visible spectrum in terms of lux. The one's going to give me UV intensity, UV index, and what I'll be able to use this measurements for, this will be my spectrum calibration and response subsystem. I know lots of fancy names, but essentially what I'm doing is I've got something here on the receiving end, I know what I'm going to get with the sending end, and I've got something on the receiving end, and I'm trying to get an idea of what is the difference there. So what's the difference in terms of lux? Because this is all going to help me get an idea of what the solar cell is going to be experiencing and what kind of photovoltaic response I can predict from there. So lots of stuff still in work, got lots of soldering to do, lots more to program, but it's starting to really come together and become an actual project, and then I'm going to get into the data analysis portion. So any questions, feel free to send me an email. Thanks.